Hello, geometry students. In this lesson, a review of volume of solids. Starting with volume of a prism or a cylinder. The thing about a prism or a cylinder is that it has the same shape at opposite ends. We think of the base and the top. It doesn't have to be that way. It could be on its side. So here you have an example of a circle and a circle. It's the same at either end, or it could be a rectangle, or it could be a square. They all, a triangle. They all have the same formula. Find the area of the base and multiply it times the distance between those two. So looking at this one, a box, of course, is length times width times height, but if you think of this as the base, then the volume on this one is going to be the area of the base, which was 24 by 20, and then multiplied times the height, which is 10, which is length times width times height. Same thing as a box. On this one, I'm going to think of this as the base, although I don't have to. I could think of one of the sides as the base. That is also the base. So for the formula for the volume on this one is the area of the base, which is 5 by 3. And then I'm going to multiply it times the height. Height is pretty clear here that it's the 4. I believe that's 60. And it's always going to be cubic units. And the reason for that is you're multiplying 5 times 3 times 4. You're also multiplying feet times feet times feet. So you have feet cubed. Look at this second one. This is probably the most confusing one because you have to have a base. The base in this case is not the thing that it's sitting on. It's the same thing at either end. So the base has to be this triangle here because you have it repeated at the other end. So the base is actually a triangle. I'm going to sketch a picture of what I want my base to be. It's a right triangle that has a leg of 6 and a leg of 10, and I don't know what the hypotenuse is, and frankly that's good. I don't need the hypotenuse. I need to find the area of this triangle. Well, the formula for the area of a triangle is 1/2 base times height. A different base. So for this triangle, remember the base and height have to be at right angles to each other, so no problem here. That's actually meters squared, but I'm not going to worry about that for now. This is the area of the base. The formula for the volume is the area of the base times the height. Well, I just found the area of the base is 30, and I'm now going to multiply that times the height, which is kind of weird, but it's the distance between the bases. It's 5. So the volume of that cheese wedge, as I call it, is 150 meters cubed. And what's confusing about it is that this is my base, even though it doesn't sit on the base. If you were to turn it over and have something that looks like this, it might be easier to see. The same thing's happening on this mark. I've actually got, this has to be my base. It's the only option. And then this is going to be, and you have to be careful about this because they don't give me all the units the way I want. So I have a right angle here. This side is 6. This side is 8. And the hypotenuse they tell me is 10. Well, I'm not going to use the hypotenuse at all on this. This 11 is actually the distance between. So if I want to find the area of this base, it's multiply the two legs, 8 and 6, and then divide by 2. I say 1/2 base times height, but it really is just multiplying them together and divide by 2. Now that I know the base, I can now find the volume by saying base times height, 24, times, in this case, the distance between the two is 11. It doesn't look like a height because it's on its side, but it is. And I think there's a 6 in this. 264. And that is cubic yards. And those are the most, this type I think is the most difficult because it's hard to see what the base is. But remember, for a right prism, It's base, and the base has to be the same at opposite ends. It's the same thing for the volume of a cylinder. You find the area of the base. It has to be the same at either end. Well, my base on this one is obviously a circle. So the formula for the area of a circle is pi r squared. So the area of this base is, I'm actually going to say r squared pi. It's easier to say pi r squared, but it's better to write r squared pi. Well, that's my area of the base. The volume is actually going to be 9 pi, the area of the base, times the height, which is 8. Now notice I did not get a decimal approximation for this. That's because it's easier to do without it, but most people are probably going to want to know what the decimal approximation is. This is 72 times pi. The decimal for that is 226.19. Don't get confused and say 72. It's actually 72 times the number pi, which is 3 point something. Same thing over here. There's my base. Now, you actually have a different formula for the volume of a cylinder that actually includes the base. That's the base, and that's the height. So I'm just going to go ahead and plug it into the formula for the volume of a cylinder, which is still base times height. It's pi times radius. Remember, it's the radius. You never use the diameter. The radius on this is 5. And then you're going to go ahead and multiply it times the height. And there's the answer. And again, I'm going to find the decimal approximation for it. And that is 235.62. That is volume for any right prism where you have the same shape at the top and the bottom. Now that leads into the second type, which is a volume of anything that comes to a point, a single point that you can actually poke yourself on. If then what you have is you have the same formula, base times height, but you now divide it by 1/3. Excuse me, you divide by 3 or multiply times 1/3. This is actually pretty amazing if you think about it. If you have this cone, if you have a can or a cylinder that it goes in, to find the volume of the cylinder, it's base times height. Well, to find the volume of a cone that fits in that, you just take that same thing and divide by 3. Don't forget to divide by 3. It's the most common mistake I make. And incidentally, it doesn't matter where the point is. It can actually go off to the side, and it will still be the same thing. So with that in mind, don't forget to divide by 3. Formula for the volume of this pyramid is 1/3 base, which is 3 by 3, times height, which is 4. And I believe that's 12. It's still cubic centimeters. This one over here is actually a lot more complicated. A couple of things. First of all, it is a square base. So this is 40 by 40. It didn't tell me that. It would have told me in the instructions originally. So I'm going to go ahead and find the formula, find the area of the base so that I can then do 30 by 1/3 of that. That's equal to 1600. That happens to be feet square. But on this one, I've got a problem because I don't know the altitude, but I do know what's called the slant height. The slant height is how far I walk up the side, but it doesn't tell me how high I am. And then furthermore, what I have is a right angle here, so I know this has to be 20 because it's half of the 40. I only want half of it. This is a cross section of it, and of course what I have is Pythagorean theorem. So plug in your hypotenuse, which I don't want, to find the height. And I now found the height is 15. So volume is 1/3. Area of the base I found that was 1600. And I just found the height was 15. Don't forget to divide by 3. You've done all this work, and sometimes you'll forget. How about a cone? This is probably a little bit easier. There is a formula for the volume of a cone. It's 1/3 base times height. Well, don't forget to multiply times pi. What's this? 2,000 over 3 pi. Now this is an example of where that gives you the decimal approximation probably makes more sense. Trying to find the decimal approximation. It is actually 2094.40. What I mean is your calculator is not likely to give it to you in this form. So I actually went with decimal approximation right off the bat on that one. Let's see. 1/3 pi r squared. Make sure you use the radius and not the diameter. The radius is only 2 on this one. 8 pi. And notice the difference between these two. 8 pi is a nice, neat looking number, whereas opposed to 2,000 over 3 pi, it's not. But I am still going to get a decimal approximation. It's about 25. That's anything that comes to a point that you can poke yourself on. That's 1/3. And then the final volume formula is the easiest one. It's the volume of a sphere. I only need to tell you one piece of information, and that's the radius. The thing that's confusing about this for some people is raising it to the 3. So I have to find the volume of a sphere with a radius of 5. The formula is kind of weird looking. 4/3 pi r cubed. Well, my radius is 5, and I'm going to cube that. And then just plug it into your calculator. I'm going to go straight to the decimal. 523.60. I don't even have to give you a picture. I can just say volume of a sphere with a radius of 7 meters, 4/3 pi times 7 cubed. That's my favorite time of day. That's why I wanted to write it down. 343. 343 times 4 by 3. My decimal for this one is 1436 and 76 meters cubed. And that's that.